So now going back to page 2 of our workbook, we're in the middle part and we want to talk about domain and range. So a relation is a rule or correspondence that assigns elements x in a set called the domain to the elements f of x or y in the set called the range. The domain represents a set of all possible independent values, inputs. The range represents all possible dependent values, outputs. For example, consider the equation y equals x squared. Since you can plug in a positive number, a negative number, or 0 for x, and you always will get an answer for y, then the domain would be all real numbers. However, whether you plug in a negative number or a positive number for x, since the value is being squared to get y, y will always be a positive number. Also, if you plug in 0 for x, y would be 0. Hence, no matter what we plug in for x, the y values will be positive 0. That means the range is 0 and the positive real numbers. Okay, another example. The cost of ground beef is dependent on the amount in pounds of ground beef in a package. So if the weight of the meat would be the x value, the price of the meat would be the y value. Thus, the domain would be all possible weights of ground beef you could buy, and the range would be all possible prices you would pay for the ground beef. So let's go back to our workbook. We're going to turn to page 5 and right in the middle. So just kind of a quick reminder. Introduction to domain and range of relation. Domain is a set of possible independent values in the relation, the x values. The range is a set of all possible dependent values in the relation that can be deduced from the domain values, the y values. So we want to find the domain and range of the following relation from the amount of gallons unleaded gas purchased and the cost of different consumers at the local Quick Trip. So here we have our points: 5 gallons, $15, 10 gallons, $30, 12 gallons, $36, 20 gallons, $60. So my domain are my x values. So it would be the amount of gas we're purchasing. So that'd be 5 gallons. I'll just abbreviate gallons, G-A-L. 10 gallons, 12 gallons, and 20 gallons. Those are all my x values, are all my first coordinates. The range is the actual money paid, so it'd be my y values, the 15, 30, 36, and $60. So it'd be 15, 30, 36, and 60. And then problem number says create your own set of 5 ordered pair that represents a real world example of domain and range. Alright, so let's say we're buying something. Let's say we're buying a drive that cost $50 per terabyte. So here would be my real example. So if I've got a 1 terabyte drive, that'd be $50. 2 terabyte drive, $100. 3 terabyte drive, that'd be $150. 4 terabyte drive, $250. And 5 terabyte drive would be, that should be $200 for 4 terabyte, my bad. And a 5 terabyte would be $250. So we just kind of made these numbers up. So my domain here, again, would be all the x values. Be 1, 2, 3, 4, and 5. Now, a lot of times when you enter this in ALEKS, they're just going to have you enter a number, so you might just be writing as your input is 1, 2, 3, 4, and 5. So you might have to write it that way without the terabytes on there in ALEKS. So if you were to do the range, you can do 50, 100, 150, 200, and 250. And again, you may need to put it without the units. It will just kind of depend what they ask you for in ALEKS. So just make sure you read the directions carefully. All right, let's turn the page. And these are some additional exercises, so just some more practice. So here I want to find the x and y intercepts. So x-intercept, I'm intersecting the x-axis. That's intersecting at -1. Again, I need to write that as an ordered pair to make ALEKS happy, so I need to write that as -1, 0. My y-intercepts, I have 2 of them. One at -2 and one at 2. Again, I'll need to write this as 0, 2 and 0, -2. You write them as ordered pairs. For number 2, our x-intercept would be -2. So again, I'll write that as -2, 0. Notice it does not intersect the y-axis. So there is no y-intercept, so we will put none here. All right, skip down to number 3. So looking at my x-intercepts, it looks like that's going to be about a -5 and 9. So again, I'll write those as ordered pairs. -5, 0 and 9, 0. Now for my y-intercepts, I'm going to have to estimate them because they don't line quite nicely on the grid. So you got one here and one here. So this would be 7 here, halfway between 6 and 8. So that's 6.5 and 7. So it looks like it's about halfway between 6.5 and 7. So maybe 6.75. We're just kind of guesstimating here. And we have another down here, it's about the same thing, except it's going to be a negative 6.75. So we're just kind of guesstimating on those. Now on this one, notice this one does not intersect the x-axis. So for the x-intercept, we would put none. Y-intercept looks like about 3.5. So we'll do 0, 3.5. Let's go and turn the page. Alright, so we have to find the coordinates of the intercepts. Remember, whatever intercept you're looking for, you're setting the opposite variable equals 0. So if I'm doing my x-intercept, I want to set y equals 0. Now it'll give me a -4x plus 2 times 0 equals a -40. That's just a -4x equals a negative 40. If I divide both sides by a negative 4, that gives me x equals 10. So my x-intercept would be 10, 0. Let's go after the y-intercept. Here I'm going to set x equal to 0. And when I plug that in, that's going to leave me with 2y equals a negative 40. We're going to divide both sides by 2. Gives us y equals a negative 20. So my point here is going to be 0, negative 20 for my y-intercept. Let's try this next one. So here, again, if I'm going after my x-intercept, I'm going to set y equals 0. And that term's just going to disappear. So I'm going to kind of skip that step and just write 3x equals 36. We go ahead and divide both sides by 3. That gives me x equals 12. So my x-intercept is 12, 0. And to get my y-intercept, I'm going to set x equals 0 again. This term's going to disappear. Just leave me with a 6y equals 36. If I divide both sides by 6, I get y is 6. So that point would be 0, 6. Alright, so now suppose that the relation g is defined as follow. G equals 3, r, p, 2, 3, m, 5, 12. Give the domain and range in G, write your answers using set notation. This is what they call set notation. So again, for my domain, I'm looking at the first coordinates. Now notice here this 3 repeats. So I write down the first 3, my P. That 3 repeats. I do not write it down again because I've already got it on my list. And then my last value would be 5. And then for my y values, I have r, 2, m, and 12. And then let's try number 8. So again, doing the same thing. I'm going to first look at my x-coordinates, my first coordinates. So we have a pound sign, dollar sign, at sign, and a plus sign. For my range or my y values, the second coordinates, I have 5 repeating, so I'm going to only write that down once. 7, 5, and 3. And then I'm just going to stop there. Again, I don't want to write down the 5 twice. We want to write down once. Alex won't like that otherwise. So that would be our answer.